Hello friends, welcome back to our channel. We are going to solve all easy problems of SQL in this video. So the first problem is query all columns for all American cities in the city table with population larger than 100,000. The country code for America is USA. So we have to populate all the records from city table, and the condition is population should be greater than 100,000 and the country code is equals to USA. We'll execute this query. Yeah, we have successfully solved the first problem. Coming to the second problem, revising the select query second. Query the name field for all American cities in the city table with population larger than 120,000. The country code for America is USA. So we have to print all the name of the city. Okay, so select city from city table. Okay, we have to print the name of the city. Okay, name from city table where population greater than 120,000. Yes, and country code is USA, and country code equals to USA. We'll execute this query. Yes, we have successfully solved the problem. Coming to the next problem, query all column or attributes for every rows in the city table. So we have to fetch all the records from the city table. So we will write select star from city table simply, and we will execute this query. Yes, we have successfully solved the problem. Coming to the next problem, query all columns for a city with the ID 1661. Okay, so we have to write select star from city table where ID equals to 1661. We'll execute this. Yes, we have successfully solved the problem. Coming to the next problem, query all attributes of every Japanese city in the city table. The country code for Japan is JPN. So we will simply select a star from city table where country code equals to JPN. Okay, COU. Okay, now we will execute this. Okay, great, we have solved this problem. Coming to the next problem, query the names of all the Japanese city in the city name. The country code for Japan is JPN. So we have to select a star from city table, and where country code equals to JPN. Query the names. So we have to query only the names. So, okay, so not the star, we have to enter name only. Now we'll execute this. Okay, we have successfully solved this problem. Coming to the next problem, Query a list of city and state from the station table. The station table is described as follows. So we have to print only the city and state name from the station table. So select city comma state from station. Okay, that's all. We'll execute this query. Okay, we have solved the problem. Coming to the next problem, weather observation station 3. Query a list of city names from station for cities that have an even ID number. Print the result in any order but exclude duplicates from the answer. Okay, so we will write select distinct city name from a station where ID mod 2 equals to 0. We'll execute this query. Okay, we have solved the problem. Coming to the next problem, with the observation station 4, find the difference between the total number of city entries in the table and the number of distinct city entries in the table. So we have to find the difference between the number of city entry minus distinct city entries. So select count of city, then we have to subtract count of distinct of city from a station, and we'll execute this query. Yes, we have successfully solved the problem. Coming to the next problem, weather observation station 5. Query the two cities in a station with the shortest and the longest city names, okay, as well as their respective lengths. So we have to print the city name and the length of that city name. If there is more than one smallest or largest city, choose the one that comes first when ordered alphabetically. So we have to print the city name and length of the city name wherever the city name length should be the smallest and the largest. And if there is more than one city with the same smallest number, then we have to order the data with alphabetically and we have to select only the topmost record. So we have to enter select top 1. Okay, now we have to take city name and the length of the city. Okay, top 1 city and length of the city. Okay, from station and then we need to group by city, and then we need to order by length of the city and then city. Now we'll again write this query for the maximum length of the city. It is in ascending order, we need to write here descending order, and we'll execute this query. Yes, we have successfully solved the problem. Okay, coming to the next problem, weather observation station 6. Query the list of city names starting with vowels from station. Your result cannot contain duplicates. So select distinct city name from station table where city like, so the name of the city start with vowel. So what are the vowels? We have 5 vowels: A, E, I, O, U. So the name of the city start with vowel and percentage sign, so that the name of the city start with A, E, I, O, U, and some other characters should be there. We'll execute this query. Okay, we have successfully solved the problem. Here I want to mention one point. If we want to use separately the vowel A, E, I, O, U in the filter, we can do that too, but this is feasible only when we have 1 or 2 characters. But if we have more than uh, 2 or 5 characters, then in such cases we should use the string method here. Okay, coming to the next problem, weather observation station 7. Query the list of city names ending with vowels from station. Your result cannot contain duplicates. Similar question is this: select city name, distinct city name, from station where city like, what we have to do, the name of the city ends with vowel. Okay, so we will add percentage sign first, then the list A, E, I, O, U. We'll execute this query. Yes, we have successfully solved the problem. Coming to the next problem, weather observation station 8. Query the list of city names from a station which have vowels as both their first and last character. Your result cannot contain duplicates. Similar type of question is this: select distinct city from a station table where city like start with vowel A, E, I, O, U and ends with vowel A, E, I, O, U. Okay, we'll execute this query. Yes, we have successfully solved the problem. Coming to the next problem, weather observation station 9. Query the list of city names from a station that do not start with vowels. Your result cannot contain duplicates. It is also a similar type of problem. Select distinct city from a station table where city like the city name should not start with vowel name. So for that we will use upper arrow, this one, A, E, I, O, U, and then percentage sign. We will execute this query. Yes, we have successfully solved the problem. Coming to the next problem, query the list of city names from a station that do not ends with vowel. Your result cannot contain duplicates. So this is weather observation station 10 problem. It is also a similar type of problem. Select distinct city name from a station table where city like. So what is the condition? City name do not ends with vowel. Okay, so percentage sign here, then list of A, E, I, O, U with not equals to sign, that is upper arrow. We will execute this query. Yes, we have successfully solved the problem. Coming to the next problem, weather observation station 11. Query the list of city names from a station that either do not start with vowel or do not ends with vowel. Your result cannot contain duplicates. So we will write select distinct city name from station table where city like. So what is the condition? Do not start with vowel A, E, I, O, U. Okay, or do not ends with vowel, right? This is the condition. We will execute this query. Yes, we have solved the problem. Coming to the next problem, weather observation station 12. Query the list of city names from station that do not start with vowel and do not ends with vowel. Your result cannot contain duplicate. Okay, so we will write select distinct city from station where city like do not start with vowel and do not ends with vowel. So we have to use not equals to A, E, I, O, U percentage list of not equals to A, E, I, O, U. We'll execute this query. Yes, we have successfully solved the problem. Coming to the next problem, higher than 75 marks. Query the name of the student in students who scored higher than 75 marks. Order your output by the last three characters of each name. If two or more students have names ending in the same last three characters, secondary sort them by ascending order. Okay, so we will write select name from students table where marks greater than 75, order by so we have to order by last three character of each name. Last three character, that is right of name by 3 digit. If two or more students both have names ending in the same last three characters, secondary sort them by ascending orders of ID. So ID, we will execute this query. Yes, we have successfully solved the problem. Coming to the next problem, employee names. So write a query that prints a list of employee names from the employee table in alphabetical order. So we will write select name from employee table, order by in alphabetical order we have to order. So order by name, enter. Yes, we have successfully solved the problem. Coming to the next problem, employee salaries. So write a query that prints a list of employee names for employees in employee having a salary greater than $2,000 per month who have been employees for less than 10 months. Sort your results by ascending employee ID. So select name of the employee from employee table okay, for employee table having a salary greater than $2,000 per month where salary greater than 2000 who have been employees for less than 10 months and months less than 10. Okay, sort your result order by employee ID. Employee ID as ascending order. Okay, by default it is ascending order. Yes, we have successfully solved the problem. Coming to the next problem, types of triangle. So write a query identifying the type of each records in the triangles table using its three-side lengths. Output one of the following statement for each records in the table: equilateral. So a triangle is equilateral if all the three sides of the triangles are equal. Isosceles, if any of the two sides are equal, then the triangle is isosceles triangle. Scalene, if none of the sides are equal, all the three sides are different, then scalene, not a triangle. So if sum of two sides of a triangle is not greater than the third side of a triangle, then such type of data will not represent a triangle. This is also mentioned here, value in the tuple. So with the example they have explained here, then when it is a triangle and when it is not a triangle. So coming to the solution part, we have to select from triangle table triangles TRIA, okay, triangles table. And now what we have to select, we need to use case function here. Case when the sum of two sides of a triangle is greater than the third, then only it is a triangle. Means the sum of any two sides of a triangle must be greater than the third side. So case when A plus B greater than C, okay, then it is triangle. Then it is triangle. Else it is not a triangle. So else it is not a triangle. Okay. Okay. Now we have identified the triangle and we have to split this triangle into further three categories: equilateral, isosceles and scalene. So again we will use case function here. Case when A equals to B and B equals to C, then such type of triangle is called as equilateral triangle. Then it is equilateral triangle. Okay. When A is equals to B and B is equals to C, then equilateral. Else we will use again when function here. Okay. When A equals to B or B equals to C or C equals to A, means any two sides of a triangle are equal, then it is isosceles triangle. Then it is isosceles triangle. Okay. So when all three sides are equal, then it is equilateral. When any of the two sides are equal, then it is isosceles. Else it is scalene. Else it is scalene. And then we will end this inner loop. And now we will execute this query. Okay, we are getting error, incorrect syntax near from. Else, okay, we have not ended the second query. Now we will execute this. Okay, successfully we have solved. Coming to the next problem, the pads. Generate the following two result sets. Query all alphabetical ordered list of all names in occupations, immediately followed by the first letter of each profession as a parenthetical, that is enclosed in parentheses. For example, an actor name a doctor name D. Okay, and then we have to query the number of occurrence of each occupation in occupations, sort the occurrence in ascending order, and output them in the following format. Okay, this is the format. Okay, these are the table, and this is the sample output. So we have to select, we have to use concate here because we have to concate parenthesis and name too. Then name comma, then we have to concate parenthesis, then left of occupation. Okay, then again, so we need to give the number of letters, only first letter we want. Okay, next we have to close this, we have to close the parenthesis. Okay, and we extracting this information from table occupations. Okay, and I think we have to ordered also, immediately followed by the first letter of each profession as parenthetical. For example, this alphabetically ordered list of all names. So we have to order by name. Okay, the first problem is solved. Coming to the second problem, select, and again we have to concate, and this is the letter we have to concate. There are a total of, then we need to give a space, then we have to count the occupation, count of occupation. Okay, again we have to give the space. Okay, then we have to lower the occupation, lower the case of occupation. Okay, because we need in the lower letter, and then we have to concate s dot. Okay, and we are extracting this from occupations table. Okay, we have to group by occupation, and then we have to order this, order by. Okay, let's see, sort the occurrence in ascending order. Okay, and output them in the following format. So we have to order by count of occupations. Great, let's execute this query. Okay, we are getting an error, line number 5, invalid column name occupation TION, there must be TION, so we have missed I, this is a spelling mistake. Let's execute this again. Yes, we have successfully solved the problem. Coming to the next problem, occupations. Pivot the occupation column in occupations so that each name is sorted alphabetically. Okay, and displayed underneath its corresponding occupation. The output column header should be doctor, professor, singer, and actor respectively. Print null when there are no more names corresponding to an occupation. So this is the occupations table. Here two columns are there, name and occupation. Okay, and we have to print the output in this format. Okay, so we have to pivot this data. Okay, so select, I will use case function here. Case when occupation, okay, when occupation, we have occupation column, so when occupation equals to doctor, okay, then we want to return the name of the people who is doctor. So case when occupation is equals to doctor, then return the name, okay, and we are going to alias this as doctor, okay, as doctor. Okay, so we need to end this case also here. Case when occupation is equals to doctor, then name end as doctor. This is the first column of the pivot. Do the similar thing for the remaining occupations. So the next occupation is what? Professor. Professor, professor, and here also we have to write professor. Okay, and the next occupation is singer. Next is singer, so replace this one with singer. Okay, great. Coming to the next occupation, actor. Next occupation is actor. Okay, we have created 4 columns: doctor column, professor column, singer column, and actor column. Now we have to create one more column, row number of this. So row number over, I will partition this with the occupation. So partition by partition by occupation, okay, and order by name, I think, yeah, right, order by name as row number, let's suppose, and all these we are extracting from the table occupations. Okay, occupations, great. Let's execute this and see how we have created the doctor, professor, and singer and actor columns. Okay, yeah, see here how we have taken the outputs. This is the doctor column, this is the professor column, this is the singer, and this is the actor. Okay, and we have partitioned these using the occupation. So this is the first one, actor. This is the actor column, and we have also used order by name. Okay, so order by name means by ascending order. Okay, so this is the output. Now we have to eliminate this unnecessary nulls from this answer. So for that I will treat this as t table. Okay, from, okay, I am from this table, the table which we have created just now. From this table we have to extract the information. Okay, so what information we have to extract? Select maximum of doctor. Okay, we have aliased the table, so write here t dot doctor. Okay, maximum of t dot doctor, comma maximum of t dot professor. Okay, comma maximum of t dot singer, comma maximum of t dot actor. Great, and we are selecting this from t table. From, okay, we have also already given the from statement. Okay, now we need to group by, because we have aggregated data. Group by row number. Okay, and I think we need to sort the data also, the output, the column header. Okay, sort alphabetically and displayed underneath its correct. Okay, we have already ordered by the name, so it's not a big deal. Now we execute this query. Great, we have solved the problem. Coming to the next problem, binary tree nodes. Okay, so we are given a table BST containing two columns, n column and p column, where n represents the value of node in binary tree and p is the parent of n. Okay, so write a query to find the node type of binary tree ordered by the value of the node. Output one of the following for each node. Root if node is root node. If node is root node, then we have to print root. Leaf if node is leaf node. Okay, inner if node is neither root nor leaf. So this is the table, sample table, and we have to generate the output in this format, and this is the binary tree. So this, in this example, 5 is the root, 1, 3 and 6 are the leaf, 2 and 8 are inner. Okay, so we have to generate the output in this format. Okay, so we have to select, we have to use case function here. Case when n is null. Okay, when n is null, then when n is null, then sorry, it's I am getting it wrong. When p is null, see, corresponding to 5, there is a null value in p, parent column. So when p is null, then we have to concate, I think, yeah, concate n and space 2, n space root. When p is null, then the n value is root. So case when p is null, then concate n as root. Okay, and similarly write here when n in select distinct p from the table name is BST. Okay, we are selecting distinct value of p from the BST table and we are comparing with the n. So if n is present in p, then it is inner. Then it is n is what? Then n is inner. So we will copy this and paste here and to change this as inner. Okay, INNER. Okay, else it is leaf. Great, from BST table. Okay, now read the what the question is asking. Write a query to find the node type of binary tree ordered by the value of the node. So we have to order this, order by n. Let's execute this query. Okay, we are getting error because we have not ended the case clause. Let's run it again. Yes, we have successfully solved the problem. Coming to the next problem, new companies. Ambers Conglomerate corporation just acquired some new companies. Each of the companies follows this hierarchy: founder, lead manager, senior manager, manager, and then employee. Given the table schemas below, write a query to print the company code, founder name, total number of lead managers, total number of senior managers, total number of managers, and total number of employees. Order your output by ascending company code. Good. So this is the structure of the table. We have company table. Here we have columns company code and founder. We have lead manager table. Here the column is lead manager code and company code. So company code is common in both the table. Next is senior manager table. So senior manager code, lead manager code, and company code. Again company code is common here. Then the manager code, manager table. So here we have columns name, manager code, senior manager code, lead manager code, and company code. Again company code is common. And the last table is employee table, which consists of employee code, manager code, senior manager code, lead manager code, and company code. Okay, coming to the question, we have to solve this problem step by step because huge number of tables are here. So first is write a query to print the company code. We will analyze all this table for our convenient. So first we need to select company code, c dot company code. Then we need to select founder name. So founder name is present in company table itself, c dot founder. Okay, we are extracting this from table company as c. Okay, coming to the next part, total number of lead manager. We have to count total number of lead manager. So I will use distinct function here because we have to count the distinct id, distinct lm dot. Let's see the lead manager table, lead manager. Okay, so lead manager code we have to count, lead manager code. Okay, next we have to count, so let's join this, otherwise we will forget. Join lead manager table as lm on lm dot company code lm dot company code is equals to c dot company code. Okay, next we have to join which table? Total number of senior manager we have to count. Okay, so count distinct. Okay, senior manager sm dot. Let's see the senior manager table. So we have to count the senior manager code here, senior manager code. Okay, let's join this table to join senior manager as sm on sm dot company code is equals to c dot company code. Okay, let's come to the next selection. We have counted senior manager code. Now we have to count total number of managers. So count distinct m dot, let's see the manager table. We have to count the manager code, okay, and join this also, join manager as m on m dot company code is equals to c dot company code. Okay, next we have to count total number of employees and order this by company code. So count distinct e dot, coming to the employee table, we have to count the employee code, and we have to join this table, join employee as e on e dot company code is equals to c dot company code. Okay, now we have to order the result, order by c dot company code. Okay, we have used aggregate function here, count, so we need to group by this. Always use group by before the order by clause. Okay, so group by c dot company code and c dot founder. So we have grouped this data by company code and founder, and ordered this result by company code. Okay, and let's execute this query. Yes, we have successfully solved the problem. Coming to the next problem, population census. Given the city and country tables, query the sum of population of all the cities where the continent is Asia. Okay, so this is the city table. We have city ID, city name, country code, district and population. Then in country table we have country code, name, continent, region, surface area, and much more things are there. So we have to sum the population of all the city. So select sum of population is present in the city table. Okay, so population, sum of population from city table as city. Okay, now we have to join country table, country as cn on cn. We have country code common in both the table, so cn dot code is equals to city dot country code. Okay, now we have to filter where continent is Asia. So continent is present in country table, so where cn dot continent equals to Asia. Okay, we will execute this query. Great, we have successfully solved the problem. Coming to the next problem, African cities. Given the city and country tables, query the name of all the cities where the continent is Africa. City.country code and country.code are matching key columns. Okay, so we have to select all the city name. Okay, so city dot name from city as city, join country as cn on cn dot code. cn dot code is equals to city dot country code. Okay, and the filter is where continent is Africa, so continent is present in country column. cn dot continent equals to Africa. Okay, let's execute this query. Yes, we have successfully solved the problem. We will submit this code. It is testing for some more cases. Yes, it is submitted now. Coming to the next question, average population of each continent. Given the city and country tables, query the name of all the continents and their respective average city population rounded down to the nearest integer. Okay, so we have to select cn dot continent. Okay, then we have to take the average of city dot population. Okay, from city table as city, join country table as cn on cn dot code is equals to city dot country code. Okay, now we have to group by cn dot continent. Okay, and yeah, and their respective average city population rounded down to the nearest integer. We have to round it. Okay, so we have to round it. So I think we have taken the average. Let's round it to the 0 decimal places. Okay, let's execute this query. Yes, we have successfully solved the problem. Coming to the next problem, the report. You are given two tables, a students table and grades table. Students contain 3 columns, ID, name and marks. Okay, grades contains the following data: grade, minimum marks and maximum marks. Okay, the question is, Katie gives Eve a task to generate a report containing 3 columns. So what we have to take the output? Select name. So name is present in a student table, st dot name, comma, grade, gr dot grade, comma, marks, st dot mark. Okay, these things we have to print. Okay, Katie does not want the names of those students who received grade lower than 8. The report must be. So first let's call the table from a student as st, join grades as gr on st dot. So what is common in both the table? Marks is common. Marks is common in both the table. So st dot marks. Here Directly marks is not common, indirectly marks is common in both the tables, so we have to use between function here. Okay, so on st.marks between gr dot minimum mark, okay, and gr dot maximum mark. Okay, we have joined the table. Now order those particular students by their name alphabetically, and if there is more than one students with the same grades, so first we have to order this by descending order by grades. So order by gr dot grades, gr dot grade or grades, let's check, grade, gr dot grade, descending order, and then we have to order it by name. So name is present in a student table, st dot name. Okay, the report must be descending order by grade, that is higher than grade are entered first. If there is more than one students with the same grade, set to 10 assigned to them, order those particular students by their name alphabetically. Done. Finally, if the grade is lower than 8, use null. Okay, we have to display all the name, whether it is whether the grade is lower than 8 or higher than 8, but there is condition. If the grade is less than 8, then we have to display null as name, and if the grade is greater than equals to 8, then we have to display a student name. So we have to use case function here. Okay, case when gr dot grade greater than equals to 8, then we have to print a student name. Okay, okay, else we have to print null, right? When grade is greater than equals to 8, then we have to print the student name, else we have to print null. Okay, we have to use end at the end of case clause to end the case clause. Now execute this query. Great, we have successfully solved the problem. Coming to the next problem, top competitors. Julia just finished conducting a coding contest and she needs your help assembling the leaderboard. Write a query to print the respective hacker ID and name of the hackers who achieved full scores for more than one challenges. Okay, so we have to print name of the hacker from the hacker table. So we have a number of tables. We will go each of the table one by one. To h dot name, and next what we have to print, that is going to print the respective hacker ID. First hacker ID we have to print h dot hacker ID, h dot hacker ID, then h dot name who achieved. So we not need this one, from hackers as h. Okay, now coming to the next part, who achieved full scores for more than one challenges. Okay, so more than one challenges, we have to find the, we have here the challenges table is there, where challenge ID, hacker ID and difficulty level is given, and submission table is there, where submission ID, hacker ID, challenge ID and score is given, and the other table is difficulty, where difficulty level and score is given. So the filter is where difficulty df dot score is equals to submission sb dot score. This is our filter, means the score is maximum, the hacker who has achieved the maximum score. We have to filter those hacker only. So we have filtered, and this is from the submission table. So just join the submission table, join submission as sb on sb dot hacker id is equals to h dot hacker id. Okay, we have joined this. Now we have to join the challenge, because we have to compare the difficulty level from the difficulty table and the challenge table. So hacker id is common and challenge id is common. Here is also challenge id. So we will join challenges table and submission table with the challenge id as common key. So join challenges as ch on ch dot challenge id is equals to submission we have called sb dot challenge id. Okay, and next we have to join the difficulty table. Join difficulty as df on df dot difficulty label is equals to ch dot difficulty level, right? Okay, we have joined all the 4 tables and we have applied the filter condition df dot score is equals to sb dot score, and we have to one more filter we have to apply, order your output in descending. Okay, we have to order this. Write a query to print the respective hacker id, name of the hacker who achieved full score for more than 1 challenges. The number of challenges should be greater than 1. Okay, so we have to group by this, group by h dot hacker id. Okay, comma h dot name. We have to group by, then we have to use having clause, having who achieved full score more than 1 challenge. So we have to count the challenge id. So challenge id is present in challenge table. So having count ch dot challenge id greater than 1. It should be greater than 1. Now coming to the order section, order your output in descending order by the total number of challenges. Okay, order by this one, count the number of challenge id. Okay, order by this. Okay, descending order, DESC, descending order by the total number of challenges in which the hacker earned a full score. If more than one hacker receives full score in same number of challenges, then sort them by ascending hacker id. and then h dot hacker id. Okay, let's execute this. Yes, we have successfully solved the problem. Coming to the next problem, contest leaderboard. You did such a great job helping Julia with her last coding contest challenges that she wants you to work on this one too. Okay, the total score of a hacker is the sum of their maximum score for all the challenges. Okay, so total score is represented as sum of the maximum score of the respective challenges. Okay, so write a query to print the hacker id, name, and total score of the hackers ordered by the descending order. If more than one hacker achieved the same total score, then sort the result by ascending hacker id. Exclude all hackers with a total score of 0 from your result. Okay, so first we have to filter the maximum score, and then we will aggregate this, sum this to get the total score. Okay, so first select what we will select. Where is the score? Score is in submission table. To select hacker id, then challenge id. Okay, and then maximum of score as sc. Okay, maximum of score as sc from submission table. Okay, from submissions table, group by hacker id and then challenge id. Okay, now we will alias this table as t. Okay, and from this table we have to select t dot hacker id. Okay, and we have to print the name. So name will be from the hacker table. Okay, so let's join the hacker table here. Join hackers as h on h dot hacker id is equals to t dot hacker id. Okay, now we have to calculate the total score of the hacker. So total score is the maximum sum of the maximum score, sum of the t dot sc as total score ts. Great. Now what we have to do, write a query to print the hacker id, name of the hacker, and total score of the hackers ordered by the descending order. So we have to order this by descending order, sum of t dot sc as descending order. Okay, if more than one hacker achieve the same total score, then sort the result by ascending hacker id. Then ascending hacker id h dot hacker id. Okay, great. Now exclude all hackers with a total score of 0. So having sum of t dot sc greater than 0. We are using having and order by and aggregate function here, so we need to group by. Okay, So group by t dot hacker id, okay, comma h dot name, okay, and order by clause should be written at the last, okay. So we have entered all the details. Let's execute this query. We are getting error, column hacker.hacker id is invalid in the order by clause because it is not contained in the either an aggregate function or the group by clause. In order by, let's use t.hacker id. Again we will execute. Yes, we have solved the problem.